All right, so the activity that we're playing with, what is a fraction activity? Is looking at a couple of different things. One thing we're exploring is a fraction is a part of a whole. But a little more deeply about that part of a whole thing we do is when we write a fraction, we're writing a division. And so a fraction is a comparison using division. And then the third thing we're trying to do here is just bring these physical models in to better understand. So we've got these physical models to try and enhance understanding. There we go. Understanding of what a fraction is. And so we had one of the first ones that gives people trouble is the light green strip versus the red strip versus the light green strip. And let's find those here. So not the dark green, you can go home, but. So looking at these right here, I can see that the red one is made up of two squares, 2 whites, and the light green one is made up of 3. So we can make the comparison that the red is 2/3 of the light green. The red is smaller, the 2/3 makes sense, but we don't have to always compare a smaller to a larger. We can compare a larger to a smaller. So the question is, the light green shape is what part of the red? And there's a couple of ways to think about that. One way to think about that is just by using the whites over, ooh, white won't go on top there. Interesting. How about you? You go on top? Huh, that one will. Oh no, and then it went away. Okay, well, that ain't gonna work. Let us make a copy of it and play on the board. So again, trying to answer the question, the red, oops, nope, I want to go the other way. Light green is what part of the red? We got to kind of expand our definition of part or fraction. Fraction isn't always a part of a whole, but it is related to some whole here. In this case, the red is kind of acting as our whole. And so our light green is that one right there. And our red, no, I did not draw that right. Let's try that again. That one looks like the dark green one. There's the light green one. So here's my light green one versus the red. And if I chop them up using the squares, I can see I have a ratio of 3 to 2 pieces, right? 3 in this one, 2 in that one. So that'd be one way to answer it, to just say that ratio of 3 to 2 is 3 divided by 2. Another way to think about it, if the red one is a whole, is that if I wanted to build the green one with red ones, I would need 1 plus another 1, but then we can see the green end of the green slices that red one in half. So to build a light green one, I need 1 1/2 of the red pieces to make the green. So we have 2 different answers there. 3/2 is one of them, 1 1/2 is the other. And it's important that we move beyond just the basic concept of a fraction, that it's smaller than 1, because there are lots of fractions out there that are bigger than 1 that we have to contend with. So this brings up the idea of this improper fraction here, which we'll talk more about, versus this mixed number over here. So just to see if this is making some sense, I got a new comparison that we're going to make. And I'm going to bring out these toys. Can I make this a little bit bigger? Come on. Probably as big as I can afford to get here. Let's make a new comparison. What I want to compare is the black and the purple. So the black piece here is what part of the purple piece there. So just write down a statement about the black versus the purple. So the purple is acting like our whole here. The black is bigger. So the fraction we come up with should be a fraction that's bigger than 1. So take a moment to think about that. Write down a sentence that you think it makes the relationship about the black being what part of the purple. So just write it down. And then if you think you have a good written statement and you want to throw it in the chat, I'd love to see what people have there. So the black strip is what part of the purple strip? So I'm hoping for a couple of responses in the chat. And then we'll go over it together. The black strip is what part of the purple? Okay, I've got 1 in the chat. I got another. Okay, hoping for one more response. Could be like or different than the other two. Somebody be brave, throw something in there. Don't worry about being wrong. Nobody should expect to get math right all the time the first time. I certainly don't. Got 2 different answers in there. I'm waiting for someone to, all right, excellent. We got someone else that comes up with one. All right, so we got 2 different answers. They are 1 3/4 and 7/4. So let's pick this apart on the screen here. Oops, wrong way. So we had the black piece and the purple piece. I don't have purple, so I'll use red. The purple piece had 1, 2, 3, 4 in it. And the black piece had 1, 2, 3, 4, 5, 6, 7 squares in it. So one way to address this is just to count and say, okay, this is made up of 7 squares. This one is made up of 4 squares. So this tells me that the black piece is 7/4 of the purple. The other way to consider it is to look at how many of the purple pieces you need to make the black if the purple is my whole. So again, I'm saying this is my purple, so I don't have the color purple on the screen. So I extend out another 1, 2, 3, 4. That takes me over to here. And I can see that the black piece goes up to that point. And so I get 1 whole one, and then 1, 2, 3 more. So that gives me another way to talk about it. The black piece is 1 3/4 of the purple. So that'd be another good answer here. All right, questions on that comparison there. So we can compare small to large with division. We can also compare large to small with division. questions? Okay, no questions in the moment. So a couple more things, and eventually we'll get to that homework question. I would like to get rid of the background, please. Thank you very much. Now, sometimes when it comes to fractions, we don't necessarily have the toys to work with. We actually have to just draw something ourselves, like I've had to do a couple of times now. So in the classroom, it's really nice to have these toys because that kind of puts most kids on a level playing field, because some kids are better at articulating on paper and in words what they're thinking, but others are not. But sometimes we do have to draw our own representations. So drawing representations of fractions. My advice is that most of us are better at drawing squares and rectangles versus circles. So I would recommend squares and rectangles, because that's easier for most of us to draw, adults and kids. Using fractions and circles is beautiful. I love circles, they're gorgeous, but drawing circles and cutting them up into pieces is a little harder than doing that with squares and rectangles. So for example, I'm gonna do some comparisons here with drawings. And we can make these drawings and show that two fractions are either equal or not equal. So these comparisons are getting at the idea of equality of fractions and the idea of inequality. It's not everything's equal. So let's start off with an inequality. So I want to compare 1/2 versus 1/3. And I think the easiest way to do it is to draw a cake, and I'm going to draw a square cake, a square thing here, as opposed to a round pie. And I'm going to try to draw them each to be the same size to the best of my ability. And if squares are trouble, just draw a rectangle, but you want to make them the same size whole so that they are comparable. And then what I do is I alter the way I draw them. So 1/2, I'll try to cut in half vertically to the best of my ability. And so this shaded part here is my 1/2. Now the 1/3, I'm going to draw the other way, and it doesn't matter too much about this, so I'm going to make my best guess at where thirds live. Usually I make marks on the side before I start drawing straight across. So this is my best estimate at thirds, and then I can pick any one of those and shade it and say this is my 1/3 here. And we could ask kids, right, hey, if this is a cake, which piece is bigger? Is the half bigger or the third bigger? And I think most kids would say, well, yeah, pretty sure the half is bigger. Sometimes we want to know how much bigger, but at least we can look and say, yeah, I'm pretty sure a half is bigger. It's not always going to be obvious. It depends on the fractions. So a half is definitely a different thing than a third. I had a different set of cuts to make it happen. To try and get at their equality or inequality more precisely, what we do is cut each cake like the other. So cut each like the other. And I think cutting them in opposite directions help make that happen. So I go over to the third cake and I make that vertical cut in half. And I go over the half cake and I identify those spots where the third should be about. Looks to me to be about there and there. And now I can see that what have I created? What kind of fraction do I have now? I could call them halves, thirds individually, but I could also call them what? Audience participation would be appreciated. Six, beautiful. Yeah, these are now 6. So I can see a half can also be represented as 3 out of 6. And a third could be represented by saying it's 2 out of 6. So that cutting each like the other, especially if I go in opposite directions, allows me to more clearly talk about how they are alike and how they different. And I can see, oh, check it out. 1/2 is definitely bigger, and I can be precise as to how much bigger it is now. I can say it's 1/6 bigger, okay? So we can take it just a step farther there. We can take that in multiple directions too. So here I'm building 1/2 into 3/6. So I built this up. We can also strip down and go the other way. So suppose I started with the fraction 3/6, and it doesn't matter too much how you draw it. So let's suppose that's my drawing there, and I have 1, 2, 3, 6 here. What I can do is I can regroup in this picture by looking for common size groups. And in this case, I'm seeing groups of 3 here. So for example, I have a group of 3 here, and I have another group of 3 here. So if I look at groups of 3, right, then I see, well, 1 out of these 2 groups of 3 is shaded. And think about regrouping. Where have we done regrouping or looking for groups before? What operation is that mathematically? How many groups of 3 are in 6? What am I doing there? Add, subtract, multiply, divide. We got addition maybe. Somebody else weigh in. What else could this be? How many groups of 3 are in 6? We certainly got it. We could look at it as addition because we have a bunch of different things here separated. What else? Division. Yeah, we could look at a division. We can look at it multiplication. The key thing here when we're looking for groups in is this is a division model. And so what I'm asking when I do that physical regrouping here, I'm saying, okay, how many groups of 3 are in 3? And how many groups of 3 are in 6? And there's 1 group of 3 in 3, and there's 2 groups of 3 in 6. So this regrouping here physically is reducing fractions. So we can build fractions up, we can reduce fractions, all with pictures, and then later talk about the mechanics of this division, which can get a little complicated. Okay, let's see, what else do we need to talk about here? Oh yeah, another idea. If we consider that, let's look at another example. How about 3/4 versus, let's go 2/3. And some kids are pretty good at looking at these and saying which one's bigger, but it kind of depends on experience, and everybody has a different experience. So let's draw these out. So draw your best square and try to make them the same size. And although graph paper is nice to get nice squares, if you have 4ths and 1/3, then graph paper becomes a little bit trickier. You're going to be a little more careful how you use the grid to do that. So let's see, 4ths. I'm going to draw the 4ths vertically. And usually if I have an even number, I like to cut things in half. And in this case, I can go in half again. So this is how I would draw the 4ths. And I would then shade that I have 1, 2, 3 of them. And the 3rds, I'm going to draw the other way. So again, 3rds, I have to kind of play around with points on the side, and that looks close enough. Okay, so shading 2 of these, and it doesn't matter which 2 you pick. All right, so here's my 2/3 and my 3/4. And which one is bigger? Well, I'm thinking the 3/4 might be bigger, but we really want to get a more definite answer. So we cut each one like the other. So I'm going to use that red, cut each like other. And Sometimes I'll use a different color for that. So this one's going to get cut in thirds. This one is going to be cut in quarters the other way. So your best artistic rendering of this. And what we end up with now is a grid that is 3 by 4 for each of these. And so we have some amount of 12ths, and some kids might be good at their area model and they can see the 12. Other kids are going to still be counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll always have a diverse arrangement of skills and abilities. And then here I have what, 3, 6, 9 of those 12ths. And here I have 4 and 4, I have 8 of the 12. So, oh yeah, the 3/4 is a little bit bigger. So I can say like that right there, 9/12. Sorry, 3/4 is a little bit bigger than 2/3 because 9/12 is bigger than 8/12. Are we always going to draw the picture? The answer is no. Like if somebody starts talking about 27ths and 36, I don't want to draw those. That's going to be painful. So we need another process. And the process is really in the cutting each like the other. When we did that, not only did the shaded regions get cut into thirds, but the whole cake got cut into thirds. And we multiplied essentially to get a bigger number of pieces. So we took our 3/4 and we multiplied top and bottom, we have by 3 in this case, since that was my recutting there. And so that's going to give me the 9/12. And this one over here, I ended up recutting the 4/4 there. So starting with 2/3, I had to cut all of those 2 pieces got cut into 4ths, and all of the 3 pieces got cut into 4ths. And so that's going to give me that 8/12. There's still a shortcut to doing this, so I can come up with that idea here. The easiest possible way to do it is to do a cross multiplication for a comparison. And so what I do is I say, okay, I've got this 3/4 here. I'm not sure how it's related to 2/3. And what I do to reconcile that is I do a cross multiply like this. And that is like the physical cutting each cake like the other. 3 times 3 is 9, 4 times 2 is 8. 9 is bigger than 8, so the 3/4 has more stuff than the 2/3. And the book talked about this algebraically with some letters. They said if you have some fraction a over b, and you want to know how it's related to this other fraction, c over d, then they show this cross multiply. They say, well, then compare a times d to b times c. So they're doing that cross multiplication there and there. And then if these are the same, the fractions are equal. If one's bigger, then it's an inequality, and you can decide which inequality it is. And it all comes back to this idea of a physical model. And that physical model, the bottom line is we need a common denominator is what we're making here. And so we're going to find in many circumstances with fractions, a common denominator is super important. And we can look at that when we're talking about the images of fractions, when we're calculating with fractions, adding, subtracting, multiplying, and so on. All right, let's pause this.